Welcome to my channel on technology space with machine learning and artificial intelligence. So today's topic is what is machine learning and AI. So let's move on to the main slides of this presentation. What is machine learning and AI? This figure represents a combined definition which is used by the research community. So machine learning is classified as a subgroup of artificial intelligence. So the deep learning, which is a modern machine learning framework, is classified as a subgroup of machine learning for an obvious reason. My thoughts on this definition somewhat slightly vary, and then let's move on to that definition. I would see machine learning as a process of transferring extreme data or informations to create AI. So the definition of machine learning I would like to use in this presentation would be it consists of various computational algorithms that can create AI. So the computational intelligence is a kind of subgroup of machine learning. And then under that framework, I would like to highlight three areas in this presentation. So the first area would be neural network. You probably heard about deep learning frameworks. So this is one of the most popular frameworks or the neural networks used by the research community. And then second area is this evolutionary computation. I would like to think reinforcement learning as a part of that. Reinforcement learning, what it generally does is it can optimize a behavior of intelligent unit that may have created by the deep neural networks. So if the intelligence is doing a good thing, it can give a reward. If it's doing something bad, it can remove a reward. So that way it can train this intelligence, or it's tune up this intelligence to behave or do a better job. Other than the reinforcement learning, I think there are many algorithms can be classified as evolutionary computation, including ASTA algorithms or genetic algorithms. So the third area would be fuzzy systems or the fuzzy logic. I think all days these fuzzy systems are somewhat popular in the area of AI. Most of the industrial applications were based on fuzzy logic due to these same reasons. At some point, I may talk about all of these areas separately, but let's move on to the next slide. So I think in this slide we kind of define what is machine learning. So then the rest is to define what is AI. So let's try to make sense out of AI. What is AI? The problem in this answering this question would be the definition of AI is changing, or our expectation on AI is changing. So initially we thought AI is kind of solving a complex mathematical problem, for example, clustering something or classifying something or doing a regression. So the clustering means you get a data set, you might break into different areas showing how dense these data are going to be. And then regression can be seen as a situation you get these data sets and then you want to curve fit this data into a specific function. So initially we thought solving this type of a complex problem is going to be AI, but it turned out that can be done easily than we thought utilizing the AI. So solving these problems is not exciting anymore. So then at some point we thought winning a game can be AI, including the playing the game. So there is one famous chess game where the human player lost to a computer. So then the excitement of utilizing AI towards playing and winning a game is not exciting anymore. So in a later stage, we thought identifying objects precisely, for example, classifying cat versus dog. As you can see, cat and dogs are somewhat similar animals, but they have slightly different features. If the AI can identify these slight different features and classify these images or these objects, we thought that can be AI, and this has been done. So solving these image classification problems is not exciting anymore. And in a more later stage, in a modern area, we thought doing some type of a human activities or human task can be AI. For example, self-driving can be one of the definitions we use for AI. And it turned out these self-driving vehicles are already on the streets. So self-driving with AI is not going to be exciting anymore. And you have to remember when we doing these, when we solving all these problems, what we utilized during this process to create AI would be we use neural. So what happened, this process is, including the self-driving vehicles, we collect human drivers data sets and then we train neural networks to utilize or identify this human behavior. And then in a later stage, we can utilize these trained neural networks to drive vehicles. So that was the process of training and creating this type of self-driving neural networks. So then you might ask the question, have we created AI? The answer would be not really. What we did so far was collecting knowledge and behavior from humans as data sets. And then we learn how to clone human knowledge and behavior through neural networks. So in a way, we learn how to preserve human behavior through deep neural networks. So it's more like we creating human behavior rather than creating something artificial or creating some sort of a intelligence in an artificial way. That has not happened. So then we end up with the initial question, what is AI? And as I have mentioned, the definition of AI has changed during those years. So I would assume that the research community would agree in general with this concept. I think our expectation of future AI would be to create human-like feeling. So creating feeling towards humans, animals, objects will be classified as AI in the future. I think there are several researchers are working towards that, but still we are far away achieving that objective. So you might even ask, is anyone predicted this? Albert Einstein once said this true sign of intelligence is not knowledge, but imagination. So that's the end of my presentation. Hopefully you have enjoyed this presentation, and if you are still interested, you are welcome to stick around. Thank you.